This is a video from section 8.3, and we're going to look at problem 3. So here's a rectangle. The height of the rectangle is 8 feet. The width of the rectangle is 2 feet. And it's 3 feet below the surface of the water. And the question is, we want to calculate the hydrostatic force on this rectangular plate. And I'm going to draw a sample rectangle here. And two things. I'm going to draw a sample rectangle, and I'm going to place the 0 at the bottom of the rectangle with the positive direction going up. Very important to be able to place that 0. Now, this is delta y, right? And the width of that rectangle is 2 feet, okay? So, I want the depth, I want the density, and I want the area. And I'm going to use this piece of information to be able to set up my appropriate integral. Now, let's take density. The density is 62.5 pounds per cubic feet. The area is 2 delta y square feet. The depth, now, the distance from this rectangle to the bottom we'll call y. The distance from the rectangle to the surface up here turns out to be 11 minus y. Okay? And so the force, this is the integral from 0 up to 8 of depth, which is 11 minus y, times the density, 62.5, times the area. Now that delta y becomes dy. Okay. Now 62.5 times 2, that's 125. And I'm going to take the integral from 0 to 8 of 11 minus y dy. So this is 125 times 11y minus 1/2 y squared, evaluated from 0 up to 8. So this is 125 times 88 minus, what is that, 32? And so this is 125 times 56. And if we were to go multiply that, right, I'm going to take 125 times 56, and I'm going to get a total of 7,000 pounds. And that's how we do problem 3. Let's take a look at problem number 7. Now, we have a triangle. So the base of the triangle is 4 meters. The height of this triangle is 6 meters. Okay? Now, I'm going to place the 0. If we want to, we're going to place the 0. Let's do this. We're going to place the 0 at the bottom with the positive going up, right? Now, the surface is up here at the top of the triangle, okay? I'm going to draw a sample rectangle here. Okay. Now, the distance from that rectangle to the base is y. So the distance from the top of the triangle down to this rectangle turns out to be 6 minus y. So I'm going to set up a similar triangle here. Here, let's see if we can make room over here. So I have a triangle. So here's 4. That's the base. The height is 6. Now, I'm going to draw a line here, okay? Now, the distance from that line to the base is y. So the distance from the top of the triangle down to this guy here is going to be 6 minus y. Now, the length of this base I'm going to call x. So I'm going to take the height of the small triangle to the base of the small triangle. So in other words, 6 minus y is to x as 6 is to 4. So 6 minus y is to x as 3 is to 2. So 3x equals 2 times 6 minus y. So I just cross multiplied. So I'm going to come over here and I'm going to say x equals 2/3 of 6 minus y. So x is 4 minus 2/3 y. I hope that's okay. So that's x. Now, we're ready. We're going to get the depth, the density, and the area. Now, let's be careful here. The depth of that rectangle is 6 minus y. So let's write that down. The density is 1,000 kilograms per cubic meter. The area, I'm going to take 4 minus 2/3 y, that's the width of the entire rectangle. So I'm going to go 4 minus 2/3 y delta y. Now, the force. Now, don't forget, we have to factor in the acceleration due to gravity. So this is going to be 9.8 times 1,000 times the integral from. Now, let's think about this. We're going from 0, the bottom of the triangle, up to the top. So 0 to 6. And then I'm going to take the depth, which is 6 minus y, times 4 minus 2/3 y dy. So this is 9,800 times the integral from 0 to 6 of. So I'm going to get 24 minus, what is that, 4y? 6 times 2/3 minus 4y plus 2/3 y squared dy. So this is 9,800 times the integral from 0 up to 6 of 24 minus 8y plus 2/3 y squared dy. So this is 9,800 times 24y minus 4y squared plus 2/9 y cubed, evaluated from 0 to 6. So this is 9,800 times. Now, if I plug in 6 for y, I'm going to get 24 times 6, which is 144. And then 36 times 4 is, well, that turns out, interestingly, to be 144. Plus 2/9 times 6 cubed. So I'm going to take 216 divided by 9 times 2, and I'm going to get 48. And I'm going to take 48 times 9,800. And I'm going to get 470,400. And the units for number 7 are newtons, so I should add that. So that's how we do problem number 7. Let's take a look at problem number 9. Now, here we have a trapezoid that's partially submerged. And the width of the base at the bottom is 8 feet, and at the top is 4 feet, okay? And the surface of the water is, let's say, here. And so the distance from the surface of the water to the top of the trapezoid is 1 foot, right? And the distance from the surface of the water to the bottom of the trapezoid is 2 feet, like so. Now, this is what I propose is basically what I'm going to do is I'm going to draw the XY plane right in the middle, right here. So here's X, and then here's Y, right? And I'm going to place the origin right here. Okay, so I'm going to give you an option of how to think about this, okay? Now, this ordered pair is, I claim, 4, 0. And the ordered pair up here, so I'm going to travel over 2, and I'm going to go up 3. So this is going to be the ordered pair 2, 3. Now, what I'm going to do, I'm going to draw a sample rectangle, and I'm going to calculate the hydrostatic force exerted on that rectangle. But we need to get a relationship between X and Y. So remember, M is 3 minus 0 divided by 2 minus 4, which is negative 3/2. So y minus 0 is negative 3/2 times x minus 4. So negative 2/3 y, right, is x minus 4. So x is 4 minus 2/3 y. But that only accounts from the middle of the rectangle to the edge, right? So 2x is 2 times 4 minus 2/3 y. That's going to account for the width of the entire rectangle. And so this is 8 minus 4/3 y. And remember, the width of that rectangle, or I'll call the thickness of that rectangle, is delta y. Now I'm ready. I want the depth, I want the density, and I want the area. The density is 62.5 pounds per cubic feet. The area, I'm going to take 8 minus 4/3 y, delta y. Okay. And then the depth, let's think about this. The distance from here to the bottom, we're going to call y. So the distance from this rectangle to the surface of the water is going to be 2 minus y. So from here, the force, and this is feet, this is square feet. So the force is the integral from 0 to 2 of, I'm going to take the depth, which is 2 minus y, times the density, 62.5, times the area, 8 minus 4/3 y dy. So I'm going to take the 62.5 out, and I'm going to integrate from 0 to 2, and then I'm going to take 2 times 8, which is 16, minus 8/3 y, minus 8y, plus 4/3 y squared dy. Okay. Now, from here, this is 62.5 times the integral from 0 to 2 of. Now, here, hold on. Let's take 8/3 plus 24/3, 32/3. So it's 16 minus 32 over 3y plus 4/3 y squared dy. We're almost done. So this is 62.5 times. So I'm going to get 16y minus 16 over 3y squared plus 4 over 9y cubed. And I'm going to integrate from 0 to 2. So this is 62.5 times 32 minus 64/3 plus 8 times 4 is 32, 32 over 9. So this is 62.5 times. Now, 32 times 9 is, what is that? 288. And then minus 192 plus 32 divided by 9. And if we pull that up in a calculator, we're going to get 288 minus 192 plus 32. And then I'm going to multiply by 62.5. And then if I divide by 9, I should come up with 8,000 over 9. Incidentally, this is approximately 889 pounds. And that's going to conclude this video for section 8.3 and also the chapter 8 review. And we looked at problems 3, 7, and 9. Thank you.